think everything is okay. Yeah, everything is okay. So this is okay for short screen. I think everything is okay. I need to pass this stream and okay. So yeah, I have written NPTEL exam on 20. I mean not 20, on August 16. So I got around 19 percentage. And percentage. So I covered 2 to 3 subjects. Fully and partially covered DBMS and discrete mathematics, I guess. Yeah. So I attempted full-length mock test. So let's solve wrong questions which I can't able to solve. Okay, these are general aptitude, can ignore it. And I think this is not general aptitude, this is discrete mathematics, I guess. Yeah. Okay, I think it's okay. Fine. Okay, let's solve this question later. And one more thing is, like, yesterday I did not do live because of some other reasons, and today I'm going to do 2 lives if possible. Okay, so this live could be on NPTEL solutions, like how I approached, and I have corrected some questions. Some of them are silly mistakes. Okay, so let me solve question from the back. Right. First question will be from 15. Okay, these are the general aptitudes. I think I'm good at aptitude. So let's solve from 15th question. So 15th question. Here what they have given was, and this question is from this question is from data structures, DS. And here they have given 3 functions. Function 1 is 10 power n. Function 2 is n log n. Okay, here the base is not n. Okay, the base is not n, so presume base has 2 or 10, anything. So let's not worry about the base. So f3 is n to the power square root of n. Okay, so I marked the answer as option B. So why I marked option B is, I thought in F2 thing n log something, and here base is n. So we all know the functions, right? So if n log x to the power n log x, the base n, here if these 2 bases are equal, then it would be x, right? And then it will be the lowest one. Okay, at some point of instance it will be the lowest one. So I took f2 as the lowest function, so that's why I marked option B, f2 and then f1 and then f3. But here what like I have observed here, so they have given the same, but I don't know whether. Okay, anyways, so if we go with the process, so let's assume f2 as log n to the base something else, it's not equal to n. Okay, in this case, so we'll get f3 as largest function. Why? Because it is exponential, like n to the power. Okay, and it's always the largest, n to the power. So if we compare here f2, what we have n in f2, we have given like n to the power again. Okay, then here log n. If you want to come, okay, I'm getting a phone, I don't know who. Okay, let me answer it. సరే పెడతాం ఫంక్షన్. Okay, I'm back. So if you see this function, like if you see here n power n, so it is exponential, it should be the greatest function. So if we do f2, it is n log n. Okay, in this function you can also say this is also exponential, but we have to compare the powers. If two functions are equal, you have to compare the powers. So we can see that log n is lesser than root n, means that root n is greater than log n. So f3 is the greatest increasing function among all. So and f2 is also it is slightly lesser than f3, and f1 we know f1 is a least function, it is like constant power n. So we can say at some point of time, at some point of n, so these three functions will behave like this constantly. So we can see f1, f2 and f3. So this will be the order. So f3 will be the, C will be the correct option. So if we notice here, I will zoom it. Wait, if I can zoom it. Yeah, you can see it here from. Yeah, you can see there in f2 this n log, they have given us base, but I don't know whether they are considering it or not. Anyways, or it's just my silly mistake. Okay, anyways, got it. So one question solved. Okay, one question solved. What next? Next question will be 39. Okay, this question, yeah, this question is from digital logics. So this question from digital logic, it is also one good question, but it is taking so much of time to solve. So if you they're given for variable function like w, x and y and z. Okay, so they are given three functions out of 4 variable. Okay, the functions are f of w0 0 comma z equals to 1. Okay, so what we have to do is we have to just draw k-map for this 4 variable function. Okay, let us try it here. Some big. This is the k-map 1, 2, 3 and 4. 1, 2, 3 and 4. Okay. So So I'm following the processes. Here should be MSB and here should be LSB. I don't know whether it's correct or not, but I'm following this. Actually, these two, this is the MSB bit and this is the LS bit. So if you consider YZ here, so it will be 0 0, it will be 0 1 1 1 1 0. Here it should be 0 0 0 1 1 1 1 0. Here we are now 0 1 2 3 4 5 6 7. Here 8 9 10 and 11 12 13 14 and 15. Okay, so what they're saying the first function is f of w00. So in place of x and y they're considering 0. So if we see x is in this 0 and here x is 0, here in this, and y also 0, y is 0 here and y 0. So in this intersection we have to make it 1. Okay, let us draw another. It would be very simple. So here we have to make 1, irrespective of anything we have to make it 1. Here intersection these two, and here are intersection of these two. Okay, done. Now what is second function? Second function we'll make it another color. It will be more simpler and easy to identify. So second function they're considering w as 1. Okay, w1 means this will we have to consider this, we consider this. Okay, w as 1 and y as 1. So where is okay y, this one we have to consider, this one we have to consider. Okay, so this intersection in this area, this square bit, so this we have to consider x plus z, the equivalent expression of x plus z. Okay, what is x here? Consider x is 1. Okay, here x is 1 means this term will be 1. We don't need to consider that. Here x is 1. Okay, 1, this one 1. What is y here? No, we have to consider from z. What is z here? Here z it is 1. Here z it is 0. So it will be 0. Fine. Yeah, fine. Okay, so then the last function was x is 1. X is 1 means we consider these two functions. Okay, these two, x is 1. We consider these two rows. So what we consider wz plus y. Okay, we consider y. What is y? We consider y these two rows, right? These two rows. Y here y is 1. Here this must be 1 and 1. Okay, here anyways it should be 1. It is 1. In this part here y is 0. So we have to look for wz. Okay, wz. Okay, here w is 0. This will be 0. 0. Here it will be 0. Here w is 1. Let's look for y. 0 and 0. That's all. W is z, right? So here it should be 1. It is 1. It is 0. Okay, fine. So this was the K-map which we draw based on given expression. So we have to look. So if we take this as 1, here we will get 2 variables out of it, and what if we consider this as 1, we get again 2 variables out of it, and if we consider this, we will get 2 variables out of this. So the answer is 6. Yeah, expected answer was 6, but I did somehow and I got the wrong answer. Anyways, it's a good question. It's good to know. This you can see the answer, and your answer is 6. So what next question? We have solved 2 questions. Done with the question. And what is this? This question. Yeah. In this question, I just marked a silly mistake. It results in -1 mark. This question, which is question from C programming. From C programming, and what they given one function as else, and function is 4,81. So okay, you have to call the function. This is a recursive type. This is very important to get. So here a is 4 and b is 81. So okay, so they are initializing C. It is an int. Okay, it is data type. So first we are incrementing. What is C? I mean, not C. They have given a counter. Counter first it is 0. So first we are entering into loop and we are incrementing to 1. That's all. So what's next? Next we are comparing b equals 0. Here b is not 0. B is 81. So 81 it is 2 power. No, not 2 power. It is 3 power 4. Not 2, yeah, it is 3 power 4. So what next? So if b is equals 3, no, it's not equals 3. Else. So they going to else, and it is c. C equals to C as they're calling same function, and just call a means 4, comma, like b by 3. B by 3 means 81 by 3. It will become 27. Yeah, 27. And then they are returning. We have to return C. Okay. In this thing, we have to return C cube. It is just C into C into C. Okay, I'm just making it simpler. Okay, this thing we don't need required. Why? Because they are asking the value of counter, how many time it is incremented, and they are not asking the value of this function. Is what is this function value? So okay, let us do. If we take further down, so after we are going to call and again this function, what will do? Just do decrement. It's called cals, like it become 4 comma, this time 27 by 3, it will become 9. Okay, 9. And then we are calling return C cube. Okay, this time also wait, here it will increment by 1, here it will increment by 2. Set here it's 4 comma 3. Okay, after column we are going to increment. Okay, wait, I just mess up with something. Okay, first we are calling 1 2 3 4, that's all. After the increment, this got incremented to 3. Okay, by this call, okay, up to this call it is incremented to 3. So it is what here we will get in return C cube, and here get again cal. Oh no, we have to check this condition. So the condition, if b equals to, so we are again passing into this, it will become 4, and then it is equals to 3. So then here it will return a cube. Got it? A cube in the sense return 4 cube. So if we return 4 cube here, the entire function will return 4 cube. So we got the counter value as 4. If you want to know this value, we have to perform recursive operation. Here this value is 4 cube. You have to return 2 here. It will become 4 cube whole cube. And so it's go on like this, and finally return like this. So let me do this. What will become 4 cube? Is it true? Like in 4 cube whole cube will become 4 power 6? Yes, that's right. If it is, I think it is true. So it will become 4 power 6. It will become 4 power 6. It will become, what will become 4 power 9. So then what next? It will become 4 power 9, right? Again it will become 4 power 12. I think this answer will be like, if we return the cal function, it will be 4 power 12. Okay, got it. 4 power 12. Okay, so we just need the answer counter, so it is just 4. So got it. So this question also okay. I just miscalculated and I written as 5. So you can check the solution here. And what's next? Yeah, this question. This question is from data structure complexity, complexity 1, and we have solved total 3 questions now, and you can see. So what they have given was, they are asking about worst time complexity of inserting n elements in an empty linked list. Okay, the linked list needed to be maintained sorted. Okay, fine. So my approach for this question was, first of all we have to insert. Okay, first of all we have to insert n elements. Okay, it takes n times. Okay, n time complexity. On this n elements, suppose the first inserted element is the largest one, so we have to sort, right? They are asking about worst time complexity. If suppose this is the largest element, it needs to travel all these n-1 nodes. Okay, so it requires n-1 comparisons. So for this one alone element, it need to travel n-1 comparisons. So by total we are going to get n square. Okay, it is order of n square. So this is what I wanted. If suppose we are going to sort in this ascending order, means if suppose if the last element is the minimum element, so we need to bring this element to the first, so it will also take n-1 comparisons. So to insert this element, it takes n times and n time complexity, and to sort this element it takes n time complexity, so the overall will be n square. So we have to sum up all this, it represents n square. So by this we get the answer as order of log n, order of not log n, order of n square. That's all. So then what next? This question. This question I will do at last for this question because it's very lengthy. I think it takes more time, and I need to do this question. I'll mark this marking. So 48 question. Okay, this question also another. And let us be set. Okay, this question is from like they're combining set theory and DBMS. Okay, number of tuples of the form A, B. I didn't cover this subject, but I have some recommendations while answering the question. In discussion, there are 3 possible, so there are A, B and S. Okay, here B is the subset to S and here it is. So if we consider there are 3 possibilities right here, to maintain this. By this here you can get 3 power 10. The total 10 elements, we are 3 possibilities, we can keep anything. So but the condition was if a if one element is present in a, and it should definitely be in b, and as we know, as is anyways it is so percent it has been present. Okay, so in this point I think we have 3 what is this? We have 3 choices, right? So 3 choices to fill this. So we have total 10 elements, so it will be 3 power 10. It will be the answer. Like as I said, I saw this question answer, and it is the simplest approach, I guess. So why they're giving it this? So if they give like if they mention C is also subset. If C is subset to A and subset or equals to, and A is subset to B and A is subset. Yes, if they given like this, here we have 4 choices. Here we can form 4 power n. Suppose n like what is this? This number of element in set contains. If this set contains n elements, we're going to do 4 power n. Why? Because we are having 4 choices: 1, 2, 3, 4. Okay. So like this, we have to do this. So it will work for all. Okay, fine. So yeah. So we all know if a set contains n elements, so total number of subsets possible means what we are doing? We are just doing 2 power n. Okay. So why we are doing 2 power n? So why? Because suppose subset is something called x as subset and s is superset. Okay. So we just have only 2 choices, right? So that's why it is called 2 power n. Okay. If we derive like this, I hope I was correct. Like this, so we get 2 power n subsets. So if we consider proper subset, then 2 power n minus 1. So you can see it here, 2 power n. After that we have to minus whole one set. Why? Because like the set itself is not proper subset. Okay, if they ask proper subset, so at least there should be one element different, I guess. So it will be the answer. I think 3 power 10 is 54049. So okay, let me remove this. I'm done with 4 questions. Go this 51 question. Okay, this question is from infinite groups of elements. Size of the largest possible proper subgroup. We are asking about proper subgroup. Okay. So I will say this question how I marked 84 as answer. Means they're asking infinite groups of 84 elements. Okay, they're having infinite groups on 84 elements. Suppose there are 84 elements are there. They're saying infinite groups. Okay, they're saying using 84 elements they are forming infinite groups. Okay, the size of the largest possible proper subgroup is largest possible proper subgroup. I don't know about this question. I need to look into it, and it is from, I think it is from a set theory from discrete mathematics. Like I didn't study this much and this question as well. So that's why I just saw the answer. So this question I can able to understand it well. So that's why I was saying. And this question not getting. They are using some Lagrange's theorem. So I know to this topic. So okay, let's not do this question here. We'll look into later. 60 question. 60 question. Yeah, this question is very interesting, and it is from computer networks. This question is from computer networks CN. I have not covered this question anywhere else. Okay. So I remember like fork is a function. Okay. Fork is a function which creates a child process. Okay, child process. Fork is a function which can create a child process. I remember just this. Okay, let us know how many total child process created. So they are given the one loop, for loop. It runs from 0 to, I think my ink is, let me wait. Okay, I'll just put some ink. A minute. Okay, done. I think now it will work perfectly fine. So you can see fork is a function. Is it okay? I think it's yeah, now it is okay. Fork is a function. Oh. So fork is a function. It creates, so if we call this function, it creates one child process. Okay, child process CID. Okay, it means child ID. Okay, it will create one child ID, and I marked our answer as 5. Okay, and let me say how I mark answer as 5. So the loop is running from 0 to 10. Okay, it is, you have to check here is it incrementing or not. Sometimes they'll give like loops. I mean, it's not loops, it's just I test question. Okay, I have seen some kind of questions, they 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 didn't give updating condition. So in that we don't need to do everything, we just need to write the final answer. So here if you see I is less than 10. Okay, then 0 to 10 it will increment. No, the loop runs for 0 to 9, and at 10 it will break this statement. So if we inside the for loop, if condition is I percent to w equals 0, so it will only run for odd numbers, odd users of 2. So if we count 0 to 9, total there are what, how many divisors? Total there are 5 divisors, like 0, 2, 4, 6 and 8. Okay, up these 5 divisors. So after this function executes successfully, fork is calling. So for example, 0, at 0 it is true, so fork creates, for 0 fork creates fork and it creates one child. Okay, fork and then one child. For 2, I mean for there are 5 times, right? So for this is 1, this is 2. For this parent will gonna create 2, it will gonna create 2. Okay, so in this way it is GP. So it is, so this process will create 2 and this will create 2 and this will create 2, this will create 2, and this will create 2, 2, 2, 2, 2. Okay, so we just have to do 2 power 5 here by minus 1 here. 2 power 5 total number of processor was 32. So there are totally 32 processors are there. Okay, so they are asking number of child processor. So we have to do 1 minus 1. So answer will be 31. So 31 child processor created. So yeah, this very good question, I can say. Like I attempted this question as 5, but I got to know how just increasing GP. So what next? So that's it. We just solved 5 questions. That's okay. So I said one question I will do later. So let's see which question I correctly marked. So yeah, this question is from COA. No, the whole created by the first best fit is never larger than created by the first fit. Okay. So in first fit, they're going to allocate the, what you can say that name. In first fit, the whole created by the best fit. Okay, fine. I am not able to recall this subject because I didn't study this subject very well. So I remember somehow I remember. Okay, then not somehow I know this, but move on next question. Okay, this limit question, it is quite simply, and we have to apply. What is that? We have to apply in 10th. Do you have limits? I don't know in 10th or intermediate. Okay, I think in 10th only limits were introduced. Okay, anyways, it just a intermediate concept. The given limit extends to 0 plus. It is called neighborhood. It is not 0. It is just above 0. Okay, it's not all equal to 1. It is just above 0 but not equal to 0. Okay, so we have to 1 minus e power 2 root x. Okay, we have to, if we place 0 in here, so it will become what? 0 by 0. It is undefined form. That's all. You have to do differentiate with respect to x. It is called LH rule, like L'Hospital rule. So if we differentiate root x, it will be okay. Let me do. I don't remember that formulas as well. So root x will be 1 by 2 to root x become 1 by 2 into x power 1 by 2 minus 1 by 2, it become minus 1 by 2. Okay, so it will be 1 by 2 root x. Fine. So x d by dx of x root x, it will become 1 by 2 root x. Okay, we have to, which is numerator, and denominator if we do differentiate, 1 will become 0, and here it is negative. E power x is always e power x. Okay, here in e power x, what we are doing, here doing e power x, and we are differentiating the x with respect to x. So then it will become only e power x. So here it is not x, it is 2 root x. Okay, here if we take this differentiation will become 2. I think I am over explaining everything. Okay, it is not that much to you. So I think it will become x, and it is differentiate 1 root x. So root x will be what? Here this one. It will become 1 by, become 2, right? Okay, 1 by 2 root x. That's it. So numerator is this. So if we, this 2 will cancel, and what next? It will become what? If we keep 0 here, it will be 1. E power 0 will be 1, and here it will be minus 1 by 2. It will become minus 0.5. That's it. It will be the answer, minus 0.5. So corrected. And what is next correction? And this is also same. Just have to apply limits like LH rule, and we're going to get this. And this question I had done. It's very simple and just array concept. And in here, what is the trickiest part? Trickiest part was it's nothing. What they're saying was first what they're doing, the loop is runs for 0 to 4. Okay, 0 1 2 3 and 4, and we have some condition like star b, like b is a pointer. It is gonna point a plus 4. A plus 4 means we have to take this, and 1 2 3 0 1 2 3 4. Okay, so star b is pointing to the last element minus star b minus 1. 1 in the sense we gonna point what b minus a for I equals to 1. So no, for I equal to 0, it will gonna point the same value. So for I equals to 1, it will do. No. What is it? First one is decreasing this value. Okay, decreasing only last value with respect to I, and second one is moving the pointer. Okay, moving the pointer away from the last one. So it will become as 10, and this value will become, it will decrement it. If for I equal 0, it is some will become b minus 8 will become 10, and it was become 10. So that's all, this to get cancelled. For I equals to 1, it will become as 9, and it will become as 8. Sorry, it is 1. So it is just decrementing and minus, and we have to do minus. That's so overall we get around 10 answer. Okay, I marked it question correctly, so no need to do, and that's it. And what's next correct answer? And this question, I know this is very interesting property, so this is wrong. So I want to explain this XOR property. Okay, XOR property is commutative and associated. So we have to remember this. This is very good explanation. And wait, I want to say one thing about this properties. So see, so what I have to say is what I will say, short memory. Oh no, got it here in option C. We know XOR is commutative and associative as well. So here in option C, X XOR Y, if it is equals to X plus Y, they are given. If XY equal to 0, so okay, if XY equal to 0 means like at least 1, so X should be 0, Y is 1, and Y, X can be 1, Y can be 0, so both are 0. So these are possible. So if this possible, it will become this. Okay, if we consider X is 0 and Y is 1, XY is 0. Okay, in this condition, what will become? So if we expand this, xy dash plus x dash y. So if we apply x as 0, okay, 0 to whole term will become 0, and y as 1. Okay, x as 0 will become 1, y as 1. So it will become 1. So x plus 1 equals to 1. Okay, got it. If we apply 0 0, x as 0, it becomes 0, y 0 0. So it is true for all. Okay, this one. And one more thing is here, it is XOR property. Here what we can say, I think I'll be able to see. That's it. XOR property, if x dash XOR y, it is same as this. Okay, XOR y. I can prove it because, so say if it x dash, right, so if we consider x dash and y dash plus x dash whole dash into y, that's all. Wait, what is that, sir? Yeah, that's it, right? So this is, so it will become just xy plus x dash y dash. So that's it. It is equals to x now or y. So, and one more thing is, while solving the logical circuits, we are going to get three input XNOR gate and XOR gate. So how do we solve this? This is not like something called like 2 input AND gate, no, not 2 input XOR gate or two input XNOR gate. It is quite different. You have to remember it like XOR is an odd parity checker. Odd parity means it detect odd number of ones. Got it? And XNOR is even parity checker. It detects even number of one. So if suppose we have like 0 1 0 1 0, we got this as we have connected to something called XNOR. So what will be the output in this condition? What how we have to approach means XNOR. Okay, we know that XNOR is a even parity checker. If you want to cheat, if no what cheat, if you want to see this even numbers ones are there not, yeah, even number ones, so it is output will be one. That's all. If odd number of ones is there, then that will be 0, so it will be if this is 1 instead of 0, if it is 1, then it will be, if there are odd number of 1, then it will be 0. What is this is one important concept which I learned from one discussion. So anyways, so yeah, 32 question. Yeah, this question is straight away true. I mean, I know this is just properties of DBMS. I mean not okay, this DBMS only. So let us know DBMS. So there is P tends to Q, or they are given this dependency. We can split it into no. Can you split? Yeah, we can split into Q and P tends to R as well. Yes, this is in 1 in F as well. And there is RS tends to T. So we can split R tends to T and S tends to T. Is fully dependent on RS. Okay. If we wait. Okay, here P tends to R, right? So here we can also keep instead of R, we can also pick PS tends to T. Yeah, it is 2NF also. Why? Because there is no partial dependency. So yes, think PS tends to Q. Yeah. Why? Because we can also get this. So okay, fine. So answer will be all these three, and that's it. And these questions are very simple. We know the worst time comes of the n square. Okay, well, yeah, this is very good question. Right, let me explain it. Wait, my duster. Right. I think this slide is becoming too long. I have to do PYQ slide as well. Afterwards, or I will do later. Okay, let's see after some time. We have solved, not solved. This is not commander solved. So the given n square elements. Okay, we have to insert n square elements. So here AVL tree. So let's say it is n. To insert n elements, we know the complexity worst complexity will take. So out of n to insert, and inserting n square elements into AVL tree. What's the worst time complexity of inserting n square? Inserting. Done. I stuck it here. What's the worst case time complexity of inserting n square elements in AVL tree? So okay, so this is AVL tree. So let's imagine this is one AVL tree. This AVL tree is self-balancing tree. So we have to balance the order. So what next? So to insert one element, it will take log 1 time. Okay. In the same way, we have to insert n square elements. So for one element, it will take log 1 time. For one square element, so for example, we can take if we have to do plus all this one for elements, it will gonna end up with what? I don't know how to do this. Okay, let me figure it out. For one element, it's taking log 1 time. Okay. For n elements, it will take log n to become n. For n square element, it will take n square and else n square. So n it will come out, and it is constant. It is ignored. That's it. And I think I figured out this way. I mean, it's not appropriate way, but this is the way. How did I do this again? So let us say it is like log 1 plus log 2 plus and so on plus how many elements we have spread? It's n square elements, right? It will be like log n square. So there is plus. We have to do all into like 1 to become log of 1 into 2 into 3 into 4 and so on up to n square time. It will become what? Log n square factorial. Okay.